1j. We have the antiderivative of x plus 3 over x squared plus 6x plus 11. Note that if we choose u to be the denominator, x squared plus 6x plus 11, then du equals 2x plus 6 dx, which is exactly twice what we have. So we can divide each side of this equation by 2, giving us du over 2 is equal to x plus 3 dx. So our integral becomes du over 2 times 1 over u. I'll rewrite that with the 1/2 on the outside of the integral. And the integral of 1 over u du is going to be the natural log of the absolute value of u. And in this case, I believe that x squared plus 6x plus 11 is going to be positive for all values of x, and so we are permitted to replace the absolute value symbols with parentheses. However, I think I will leave them there. It's better to leave absolute value symbols that you don't need than to drop ones that you do need. So I'll play it safe and leave the answer in this form. 1k. We have the integral of x times e to the power 5x squared with respect to x. Keeping in mind that the integral of e to the u is equal to e to the u, perhaps we can get by choosing 5x squared as u. In this case, du would then be 10x dx. We have the x and the dx, all we're missing is the 10, and that can be dealt with easily. X times dx is du over 10. So we have the integral of e to the x, e to the u du over 10. I'll pull the 1/10 out to the front and write this a bit more neatly. The integral of e to the u with respect to u is e to the u. There's our constant of integration. And we're left with 1/10 times the integral, 1/10 times e to the power 5x squared plus an arbitrary constant of integration. 1L. We have the integral of e to the x divided by the quantity e to the x plus e. This e is just a constant. It does not. This term does not involve any variable. It is just a constant term. So if you differentiated the denominator, e to the x plus e, you would get e to the x plus 0, and that's what we have in the numerator. So perhaps choosing u to be e to the x plus e is the way to go. That will give us a du of e to the x dx, which again is exactly what we have. So what we have is du over u to integrate, and that's going to be the natural log of the absolute value of u plus c. So that's the natural log of e to the x plus e plus c. I traded the absolute value symbols in for just parentheses because I know that e to the x is always positive and e is a positive number, so I'm always taking the natural log of a positive quantity here. Also, this answer does not look exactly like the answer that is provided in the solutions. I believe I prefer this version of the answer a bit better. 1n. Perhaps this is the trickiest antiderivative of the lot. Everything is down in the denominator. All the interesting things, anyway, are down here in the denominator, the x and the natural log of x. Well, I'm thinking of this as 1 over x times 1 over natural log of x that needs to be integrated. Now, remember that the derivative of the natural log function is 1 over x. So this seems like this should be part of the du then, and this could be the u. So let's let u be the natural log of x. It follows then that du is 1 over x dx, which is what we have here and here. So our integral becomes 1 over u du, which of course is the natural log of the absolute value of u plus c. U is the natural log of x, so we get the answer as the natural log of the absolute value of the natural log of x plus a constant of integration. Problem 2, parts A and B. We are asked to solve these equations. In part A, we have e to the 3x equals 51. We need to get x by itself, so we need to get rid of the e and the 3. I'll start by getting rid of the e. We know that to get rid of the e, we want to take the natural log of each side. That leaves 3x equals the natural log of 51. Or x equals the natural log of 51 divided by 3. In part B, we have the natural log of x squared minus 1 equals negative 5, and we need to solve for x. So first, let's get rid of the natural log on the left side. We'll do that by raising e to the natural log of x squared minus 1 on the left side, and we have to do the same thing over on the right side. We'll raise e to the negative 5 over here. Negative 5 and natural log of x squared minus 1 are equal, so when we raise e to those powers, we should get equality again. The e and the natural log undo one another, and so we're left with x squared minus 1 equals e to the minus 5. Add 1 to each side, and you get x squared equals 1 plus e to the minus 5. E to the minus 5 is positive because e to any real number is a positive value. When we add 1 to that number, it's going to be even bigger. So it's going to be positive. Therefore, we can take the square root of both sides safely, and we get x equals plus or minus the square root of 1 plus e to the minus 5. Number 3, we are asked to find the average value of the function f of x equals sine x on the closed interval from 0 to pi over 2. So you'll recall that the formula for the average value of a function f of x on the closed interval from a to b is 1 over b minus a. B minus a is just the length of the interval, times the integral from a to b of f of x with respect to x. So in this case, we're going to get 1 over pi over 2 minus 0 times the integral from 0 to pi over 2 of sine of x dx. I'm going to clean this up a bit. This denominator simplifies to be just pi over 2. So we're dividing 1 by pi over 2. So in other words, we're just finding the reciprocal of pi over 2, and that's going to be 2 over pi. The integral of sine of x is negative cosine of x. So we'll have 2 over pi times the negative cosine of pi over 2 minus the negative cosine of 0. the cosine of pi over 2 is 0. So we're getting 0 plus the cosine of 0, and the cosine of 0 is 1. And so what we get is 2 over pi times 1, which is just 2 over pi. 4a, we are asked to differentiate the function g of x defined to be the integral from 1 to x of t to the 7th sine cubed of t dt. You recall that if y is defined to be the integral from some constant to x of f of t dt, that the derivative will be f of x, provided that the function f is continuous on the closed interval from c to x. So in this case, g prime of x is going to be just x to the 7th sine cubed of x. 4b, we are asked to differentiate f of x equals the natural log of 2x minus 7. The derivative of the natural log of a function is 1 over that function times the derivative of that function. So in this case, we will get 1 over 2x minus 7 times the derivative of 2x minus 7, which is 2. So the answer is 2 over 2x minus 7. 4c, we are differentiating x times the natural log of 2x minus 7. Since the operation between the function x and the function natural log of 2x minus 7 is multiplication, we will use the product rule. In that case, then, the derivative will be the first factor times the derivative of the second factor. And we have already seen that the derivative of the natural log of 2x minus 7 is 2 over 2x minus 7. That's from part 4b. Then we'll have the derivative of the first factor times the second factor. So the derivative of x is 1, and we'll multiply that by the natural log of 2x minus 7, giving us 2x over 2x minus 7 plus the natural log of 2x minus 7.